Welcome back to this YouTube tutorial series on implementing numerical methods in Python, and in today's video we're going to be going over estimating derivatives. A derivative is simply the slope of the tangent line to the graph of a function at a given point. So here we have our graph in we have our function in the blue on the graph, and simply the tangent line is a straight line whose slope is equal to the slope of our blue graph at this given point. So we can see here that our tangent line does not approximate our graph at all. However, if we were to zoom in and scale this down, our tangent line closely approximates our slope of our original line. And simply, the formal definition of a derivative is the following. F prime, which is the notation for a derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. And what the limit simply means is, as h starts off as a big number and it approaches 0. So as h gets extremely small and we feed it into this function, then we will actually have the slope of our tangent line, or the derivative. And now we can adjust this equation in numerous ways to actually get the center divided difference method. Rather than actually programming the rules and regulations in mathematics to derive the derivative by hand, we can approximate it using different types of functions. So here we have the center divided difference method. F prime is now equal to f of x plus h minus f of x minus h divided by 2h plus o to the h squared divided by 6 for h small, where o, h squared divided by 6, is the error of our function. So typically in most scientific calculators, h is actually used as 1 to the one e to the negative 4. And this is simply because the error of our function is denoted by this right here. So we simply take our h, we square it, and then we divide by 6. And we eventually get this value. So our error is 2 times 10 to the negative 9th, which is equivalent to it having a tolerance of 2 times e to the negative 9th, which is an extremely accurate value. So now that we've gone over the center divided difference method, let's actually implement this in Python. So to begin with, we're going to define our function. It is going to be the following. It's going to be x to the third power plus 3 times x raised to the second power minus 7 times x plus 5. Now we're going to define our derivative approximator. We're going to feed it an x value and a function, where the x is simply the point at which we want to derive the slope. And we're simply going to return the function at x plus h minus function x minus h divided by 2 times h, where h is given by 0.0001. So there we have it. We have our function and our derivative approximator. So now what I'm going to do is I'm going to print out our estimated derivative. So we're going to say estimated derivative of x to the third plus 3 times x raised to the second power minus 7x plus 5 at x is equal to 5. So here we're going to pass in 5 and our function. So we play this out, and the estimated derivative of this function is 98. So here we're going to go to Symbolab, which is an extremely useful mathematics software and framework. So the estimated derivative using the handwritten rules of our original function is 3 times x squared plus 6x minus 7. So simply this gives us the equation of the slope. So now we just need to plug in 5 into this equation. As we can see, we do that and we get 98. So we can see here that we have accurately created an estimation of the slope, or the derivative of our original function, and we can type in more values. We can say, let's say 10.45, 10.45. So we can also type that in here. And so we had an estimation of 383.3075, and we can see here our estimation is correct. So there we have it, a short and simple way of estimating the derivative of a function. So stay tuned for future videos.